So welcome everybody, myself Shivam Rajput back again with a new video on CSIR Net JRF Earth Science video series. So today we are going to discuss about global temperature distribution, and I want to say that this is one of the very important as well as very difficult kind of topic, and most of the questions from this topic is mainly in the C section. So without wasting a time, let's begin. Now, first of all, what is temperature? Temperature means a degree of hotness or a coldness of a body. You can say that it's a amount of kinetic energy holding by the particles in a system, whether it is in solid, liquid, or gas. Now, why temperature changes? It's all depend upon the geochemical, geoptical properties of uh, that specific particle. Okay. Now we know that different bodies have different kinds of specific heat. Okay. If it has different specific heat, that means the degree of hotness will be different for different objects. If you consider latitude and longitude wise temperature difference, it will again not uniform throughout. We know that if you are on the same latitude, that means the degree of inclination of sunlight will be same, but it is not in the real world, right? What is the reason behind it? The reason is we have unequal distribution of land and water. At same latitude, some places we have ocean mass, some places we have thick forest, some places we have land, and we know that different bodies had different kinds of specific heat with them. So because of this different specific heat, the degree of hotness and coldness will be different. They absorb heat differently because their specific heat as well as their albedo will be different. Now consider an example. For example, at the same latitude in the Punjab region, we have high temperatures. At the same latitude, if you went to the northeast, there we have hill stations where the temperature will be very low. So here we can see that it's all depend on the altitude. In the northeast region, in hill station, the altitude will be very high. So temperature will technically less, right? So, and another question, at the same latitude, due to different geochemical properties of ocean, water, desert area, and all, we have different kind of temperature, right? Means if we convert the whole Earth with uniform kind of material, or you can say if we convert the whole Earth with only one ocean, whose salinity will be same, whose you can say amount of suspended matter will be same, then in that case, along the latitude, the temperature will be same, not longitude, because our Earth is not like a flat. It's a spherical, no. So as you move towards the pole, the sunlight covers more distance to go to the polar regions. So if the distance will be more, that means the intensity will be less, and in that case, the amount of insulation will be less. So these are the factors which affect the temperature. There are many more factors which affect the temperature. For example, during cloud-free days, the temperature will be more in daytime. If cloud is there, that means there is some obstruction, right? So it reflects all the incoming solar radiation back to the space. In that case, the temperature during the day will be less, but at the night time we have exact opposite condition. So during night time, if clouds are there, that means the temperature will be more, because this clouds traps this IR radiation which is going to the space. Are you getting or not? Now we are going to talk mainly about isotherms today in this topic. Isotherms. What are isotherms means? Isotherms simply means a line connecting a points of equal temperature. These are called isotherms. Iso means same, therms means temperature. Now, there are some points, general characteristics of isotherms. Okay, so they are generally parallel. If the land mass will be uniform, then they are parallel. Otherwise, they cross each other. So this condition is possible only when if the land is uniform characteristic. Land of uniform characteristic means they are geochemically same throughout the whole area. There is sudden bend at the ocean continent boundary. So as we move from ocean to continent or continent to ocean, there is a drastic change in specific heat, right? And due to this drastic change in specific heat, the whole insulation rate will be different. Now the amount of reflection, absorption, or you can say attenuation of light will be different. So it's these isotherms show sudden bend at this boundary. Third point, narrow spacing. That means rapid change in temperature. If isotherms are close to each other, that means there is a steep change in temperature. You can also say that they have high thermal gradient. In a case of a wide spacing, there is a small or slow change of temperature. That means a low thermal gradient. Getting? So if a area is very warm in nature, that means there is a narrow spacing. There is a intense change in temperature throughout that area. Getting? Now let's talk about this important points. Highest temperature tropics and subtropics. Now what is the reason behind it? Why there is a highest temperature? So first of all, we know that this tropical region is near the equator, or you can say equatorial bulge, near the equatorial bulge. So if we compare, see, if we compare this, so if we compare this with this Earth, sorry, here is the Earth and this is Sun. Okay. Now we know that both Earth and Sun are in the same plane, right? If they are both in same plane, that means it is not a correct diagram. It is something like this. It is something like this. See, this is Earth, Sun is over here. Now we can see that this is equator, this is Sun, and for this equator and for this pole, the distance covered by the light will be different. So here it is less, right? Less distance means less attenuation. More distance means more attenuation. So the intensity will be more over here. That's why in the tropical and subtropical region, we have highest temperature on the globe. So this is all about the first point. Lowest temperature, polar and subpolar region. So here we can see that in polar and subpolar region, this region from 90 degree till 60 degree. So in this region, the sunlight is at slant angle, right? It covers more distance. More distance means it passes more distance in atmosphere too. And when this electromagnetic radiation comes in contact with our atmosphere, it starts attenuating. That means it either reflects, refracts, absorbs, or transmits through the atmosphere, particular air mass in the atmosphere. So at that point of time, it loses some of its energy. And when it loses its energy, that means there will be cooling, right? Over here we have cooling. Now, third point, effect of continentally. No moderating effect of ocean. The continent ki effect. So, for example, if you are in, say, Rajasthan region, and one person is in Goa region near the coast. So you can see that during the daytime, And during the night time, the difference between the temperature will be more in the Rajasthan as compared to Goa. Now, what is the reason behind it? The reason is Goa has a effect of ocean with it. Means here the controlling factor is ocean. But in a case of Rajasthan, it is very far from the ocean region. Here during the daytime, it absorbs the energy from sun, so temperature will be more during day. During night time, it releases all the radiation in the form of IR rays to the space, and hence the temperature cools down. So the difference, or you can say diurnal difference of temperature will be more in the Rajasthan region. So this is the effect of continentality. Okay, continentality. This is the effect of continentality. Now, diurnal and annual range of temperature are listed in the ocean. Same point. Near the coastal region, the diurnal and annual range of temperature will be very list. Means there is no extreme of summer, no extreme of winter. It's like that. Temperature throughout the year is more or less same. Okay. Now, low temperature gradients are observed over the tropics. What is the reason why low temperature gradients are observed over the tropics? Because there is a very less change in temperature. That means if you are in the tropics, the whole region is always heated by the sun, right? So if you average the whole tropical region, it is warm throughout the year. That's why the temperature gradient is very low. Here we can see that in this point, low temperature gradient means small or slow change of temperature. So in the tropical region, sun is always there, no? See, this sun moves from 23-degree north to 23-degree south, 23 and a half south. This is the region in which sun moves. Actually, it's not sun moves, it's a tilt of the earth due to which sun sometimes is in the northern hemisphere, sometimes it is in southern hemisphere. So this whole region is like covered with the highest solar insolation. Now due to this, we have low spacing, low temperature gradient in the tropics, high temperature gradient over middle and higher latitudes. Why? Because, for example, temperate region, higher latitudes, over there we have 6 months. For example, poles, higher latitude. Over there we have 6 months days, 6 months night. The temperature variation will be very drastic. And whenever the temperature will be drastic, that means the isotherms will be close enough, and at the same time the gradient will be more. Then temperature gradient are usually low over the eastern margin of the continent. On eastern margin, we have low temperature gradient. What is the reason? See, we know that on the eastern margin of the ocean, continent, that means western margin of the ocean, right? If it is eastern for continent, that means western for the ocean. For example, India. This is eastern margin of the India, but for Bay of Bengal, it is western. And we know that on the western coast, we have this warm current. Warm current means what? Warm current means it is always have a high temperature, right? And in this case, the gradient will be low. Similarly, temperature gradient are usually high over the western margin. Western margin means eastern margin of the continent. Sorry, eastern margin of the ocean and western margin of the continent. Over here, we have cold currents. Now, this cold currents separates the temperature very drastically. See, for example, this is the land and cold current is moving like this. So over this land, due to high specific heat, it absorbs energy very fastly and warms very fast. At the same time, over here we have cold current. Now this, due to this cold current, temperature will be fall हो जाएगा. Now due to this drastic change of temperature over the western margin of the continents, or you can say eastern margin of the ocean, temperature gradient will be high. Now the isotherms are irregular over the northern hemisphere. What is the reason why it is irregular in the northern hemisphere only? Because northern hemisphere is a land hemisphere. Land hemisphere means land is more, ocean is less. So land has less specific heat. That means it's warm faster, it cools faster, and it affects the whole isotherms over it. Okay. Now, effect of mountains. How mountains affect the temperature? So basically, see, if at the same latitude we have desert-like condition, over there temperature will be more. At the same latitude, suppose we have a hill station like Simla and Mussoorie and all. So over there, the temperature will be less. Are you getting or not? So it's all about the altitude. Okay. Another point is, suppose this is the mountain region and this is Himalaya. Okay, Himalayas. This is Tibet region. Here we have China and all. China. This is China region. And this side we have Indo-Gangetic plain. India is like this. Okay. Himalayas are, see, this is the map of India, no? India is like this. This is Himalayas. Himalayas is like this. Okay. Now, this is the cross section. So Himalaya is going like this. This is Indo-Gangetic plain. This is South India. This is Sri Lanka. Now we know that since sun can move up to 23 degree north only, can't pass through this 23 north, right? 90 degree ka angle is always formed on 23 degree north, or from 23 degree north to 23 degree south. It can't exceed this 23 degree north. But if you see that, if sun is over here, suppose sun is over here, and the sunlight is going like this in all the direction. So this southern face of the Himalayas have more sunlight than this face, because it is in the opposite direction. No, so sunlight can't reach over there because it is like this. See, this is Himalayas, and sun is over here. So this face is illuminated. No, this face is always in the dark, or you can say the intensity of sunlight will be less over here. Now here we can see that the effect of slope, how this effect of slope affect the temperature. Now due to this reason, in the southern slope of Himalayas we have many more rivers, and on the northern part of the Himalayas we have glaciers, which is throughout the year. Here we have forests, different kinds of forest, and agriculture will be more over here. Productive region is more over here because of this heating. Are you getting? Now, so this one is very important. Okay. Now here we can discuss how the surface air temperature will change throughout the months. Now this diagram is all about January. So here we can see that how isotherms will be changed during the January month. Now January means right now sun is in the southern hemisphere, right? So during January for northern hemisphere we have winters. In southern hemisphere at that point of time we have summer. So in Australia, Australian peoples feel summer over that period of time. Now due to the presence of sun over here, the thermal equator is in the southern hemisphere. See, this thermal equator is in the southern hemisphere, below 0 degree geographical equator, 0 degree. This is here. And these are the lines, these are the isotherms which shows a particular temperature. See, this is 20 degree isotherm, this is 20, 10, 0, minus and all. As we move up, temperature decreases towards the pole. So minus is over here. Here we can't see this minus thing. What is the reason? The reason is sun is in the southern hemisphere. So temperature is not as much low as in the northern hemisphere. Over here it is not as much low. Over here on Antarctica we have 6 months daytime right now. Okay. Now you can see that the isotherms are irregular in nature. Why they are irregular? Because of unequal distribution of land mass and ocean. Second thing, the curve is more bended near the boundary region. See, boundary. On every boundary, it bends. Land or ocean boundary, you can say, it bends. And they are more concentrated in the northern hemisphere as compared to the southern hemisphere. They are more concentrated, right? Here it is more concentrated. Second thing, in the southern hemisphere, these isotherms are parallel to each other. See, these are parallel to each other, more or less they are parallel, and this one is slightly parallel, you can say. And at some point of time, it also forms this circular isotherms over some regions. That means this whole area is suffering from this 30 degrees Celsius temperature. You can also notice that on the lands, these isotherms bend towards the equator, and on the oceans, they are bent towards the pole. See, this is Atlantic Ocean, and here they are bended towards the polar region. Over the land mass, they are bended towards the equatorial region. What is the reason behind it? So the reason is these isotherms are basically wants to make the temperature equal throughout the earth. They want to achieve this equilibrium temperature. So we know that since northern hemisphere is right now feels winter, that means this land mass cools faster due to low specific heat. So land mass is now more cooler as compared to the ocean. Since ocean has high specific heat, that means it has ability to hold the temperature of previous summer. So right now over here we have high temperature waters, which is due to previous summer sunlight. While at the same time these land mass are more colder, more chiller. Now since these are colder, that means if the isotherms are over this land mass, it moves towards the or it shifts towards the equator. Since equator is always warmer, so this is cooler, this is warmer, so it moves towards the warmer region. High pressure to low pressure. Warmer regions are always on the low pressure. So high to low. They want to make the temperature in the equilibrium condition. So here temperature is less, here temperature is more. So it is shifting towards this. It's bending towards the equator. Now let's talk about this thing. Oceans. So on in the oceans right now temperature will be more as compared to the land. If temperature will be more, then it shifts towards the pole because poles are cooler. To make it neutral, it moves towards the pole. That's why the bending is towards the pole. Getting? And what is the reason that these two lines are parallel to each other? Because over here there is no landmass. Only slight changes over this point you can see. It is completely free from land. That's why it is parallel to each other. Because this whole ocean over here, this southern ocean, showing a uniform properties, uniform thermal properties, you can say. That's why it is parallel to each other. Okay. Second thing, here we can see that isotherms deviation from this general trend is more pronounced in January than in July, especially in the northern hemisphere. It is more pronounced in December or January, winters. Why it is more pronounced in winters? So see this point. Here we can see that whenever there is a rapid change, that means high thermal gradient, at that point of time the amount of isotherms per unit area will be more. Now during winters in the northern hemisphere, there is a rapid change in the temperature. That's why it is more concentrated in the northern hemisphere. See this July thing. This is a seasonal temperature distribution during July. The number of isotherms will be less because northern, in this case, sun is over here, and due to sun, this whole northern hemisphere becomes warm, and then the gradient will be low. So due to this low gradient, the amount of isotherms will be low. Okay, clear or not? Now moving to the next slide. Here we can see that this is the seasonal temperature distribution of July. During 21st June, the sun is at 23.5 degree north, and this is not a like exactly it is not on the 23.5 north, because this is the ideal condition. Exactly it is like this. See, this is the thermal equator. We know that ITCZ follows the sun, right? If it moves to the northern hemisphere, ITCZ moves to the northern. If it is moved to the southern hemisphere, this whole ITCZ moves towards the southern hemisphere. So now during this July month, since sun is over here, thermal equator is like this. And see, again, it is not a straight line. It is not following any unique or any specific latitude. It is passing over more than one latitude. And see, maximum temperature is near the Tibetan region, right? Another thing we can see that even during this month, this bending follows the same rule. Now, but in July, since the warming will be more, the gradient of temperature will be less. Due to this condition, there is a certain change in the bending at some point of time. You can see that over here it is moving towards the equator, but here we can see that it is moving towards the pole. See, this is the land mass, this is warm, so it is moving towards the pole. Right now here it is again moving towards the pole, but at some certain points like here it is moving towards the equator. So it's all due to this intense heating of the land during July. Okay, now this is all about this temperature distribution on the land mass and ocean masses. So hope you like it, and tomorrow we are going to discuss about a new topic, that is Indian monsoon. So till then, stay tuned. Bye.